Hey everyone, and welcome back to the channel. Today, we're tackling a fundamental concept in electronics that's literally lighting up your home and your car right now, the parallel circuit. If you've ever wondered why one light bulb burns out and the others stay on, you're in the right place. Stick around, because by the end of this video, you'll understand parallel circuits like a pro. So, what exactly is a parallel circuit? A parallel circuit is a complete circuit that has more than one path for current to flow. These separate paths are called branches, legs, or shunts, and the current splits up among them. The key feature of a parallel circuit is that even if one branch opens or breaks, the rest of the circuit continues to operate. That's why most household electrical wiring and automotive lighting systems are designed in parallel, because one light burning out shouldn't stop the others from working. Now, let's break down the three key laws that show exactly how a parallel circuit operates. Law 1, total resistance. The total resistance of a parallel circuit is always less than the smallest resistor in the circuit. That's because current can flow through multiple paths, like cars using several lanes on a highway. Law 2, voltage. The voltage is the same across each branch of a parallel circuit. So, every light bulb or load in a parallel setup gets the same voltage from a source. Law 3, current. The current flowing through each branch depends on the resistance in that branch. Lower resistance branches allow more current to flow, while higher resistance branches carry less current. This is where Kirchhoff's current law, also known as Kirchhoff's first law, comes into play. It states that the total current entering a junction is equal to the total current leaving that junction. In simpler terms, the sum of the individual currents in each branch equals the total current flowing from the power source. And that wraps up our deep dive into parallel circuits. We've seen how multiple paths allow current to split, how voltage stays the same across each branch, and how resistance and current balance out using Kirchhoff's current law. Remember, parallel circuits keep things running, even if one branch fails. That's exactly why your home lights don't all go out when one bulb burns out. If you found this video helpful, don't forget to hit the like button, subscribe, and turn on the notification bell so you never miss out on our upcoming videos.